So welcome to the second problem for this related rates problem. So I would like to thank Samsung Galaxy Note 8 for this opportunity to explore this new S Pen, and also Socratic.org where I got the problem. So oil spilling from a ruptured tanker spreads in a circle on the surface of the ocean. The area of the spill increases at a rate of 9 pi square meters per minute. How fast is the radius of the spill increasing when the radius is 10 meters? So the same thing with problem number 1. So we can imply that the dA over dt for the first problem was what we were trying to get. But in this problem, it's the dr over dt. So this would be for the second problem. So we need to write down the formula for the circle. So one of the easiest problems in related rates would be circles. So getting the derivative for both, dA over dt. So why is it dt? Because we're trying to get how fast. So fast means with respect to time. So pi is a constant, 2 pi r, then dr over dt. So this was how we have obtained this with implicit differentiation. So you can check my other videos if you want to learn more about how we were able to come up with this equation. But yeah, so dr over dt. So we know that the area of the spill is 9 pi square meters per minute equals 2 pi. Then we know that the radius is 10 meters and dr over dt. So r prime is also dr over dt. I think I've shown this one in the first problem. So let's write it down properly. So 2 pi times 10 meters times dr over dt. So we know that this can be cancelled out. So we have 9 pi over 2 pi times 10. So we just had to transpose this one to the other side because we're trying to look for the dr over dt. So just be extra careful when you are transposing, because other students would normally put this in the numerator when in fact this should be placed in the denominator, or just use some cross multiplication. So 9 pi over 2 pi times 10. So 10 should be in the denominator. So dr over dt, so we can cancel this. So obviously the rate of change of this radius, or the spill radius, we call this one as the spill radius, would be 9 over 20 meters per minute. So why isn't it square meters? Because we already canceled this m here, these two m's, and also the radius would always have a unit that's not squared, because when you say it's squared, it's only for area, surface area, or anything that you multiply, so that length times length, or the width, or another variable. So for this, the answer would be 9 over 20 square meters per minute. So this is positive, it's greater than 0, so it means that the radius, or the rate of change of the radius with respect to time is increasing. But if it's less than 0, it's obviously decreasing.